Hello, so today we are doing this Leetcode problem 645 called set mismatch. And so what the problem says is that we have a set that contains numbers from 1 to n, and for some reason there was a data error, and one of the numbers in the set got duplicated. So we have one duplicate number. And then we have also, so that results in a repetition in the array, and we lost another number. So one number is duplicated and another number is lost. And the array is from 1 to n, which n is the length of the array. So we are given this array, and we want to find these two numbers where one occurs twice and the other one is missing. So for example, for 1, 2, 2, 4, the length of the array is 4, so we should have from 1 to 4. So we should have 1, 2, 3, 4. But 2 here is occurring 2 times, and 3 is not here. So we need to return 2 and 3. So the array is not sorted, and its size is between 2 and 10,000. So how can we solve this problem? Let's do this here. So let's see. How can we solve this? One way we can approach this problem is using same thing, using a map that is like a counter of the elements. So if we take the value that we had, which was the example basically, which is 1, 2, 2, 4. So 1 occurs 1 time, 2 occurs 2 times, and 4 occurs 1 time. So we can go through this map here and find the values that occur more than once. That's the duplicate. And then we can go from 1 to the length of the array that we got, which is this one here. And if we find that one of them is not in this map counter here, let's call it occurrences, then that element is the missing number. So that's a very straightforward solution. So how can we do this solution here? So first we need the occurrence, and then we need to return the result, which is the list of the two elements, basically the duplicate and the missing one. And so we need counter of nins, and then we need to input Python's counter, which just does this counting the occurrences of each element of the array. And so we are going to put counter there. And our result is an array. So just to account for cases like this, let's say it's just 0, 0 that is missing. And then we can say, we can go through, so we can just say, yeah, this case doesn't matter basically. We can return empty or this depending on what Leetcode judge wants. And then what I have here is, so I want to go, so since I have the counter, I want to go through I want to go through the range so I can find the missing and at the same time find the duplicate one. So I'm going to go through the range from 1 to the length of the array and check if I find the number that is not in the occurrence, then that's the missing number, right? And so the solution wanted the missing number in the second slot of the array. And so we can just say res1 is going to be equal to 1. Now, if the occurrence is there, but it's bigger than 1, or equal to 2 probably, you can just say equal to 2, then we just put that in first position. And at the end, we return this. Yeah, so this normally should work. Okay, so we have the correct solution. Let's just test against the empty list. That's something we should always do if the input is an array. And let's test for 3. So one edge case probably is if it's the last element that is missing. So we want to test against this. Okay, so we see that we have a problem here. So we have 1, 2, 3, 4. So we should have 3 as the duplicates and 4 as the missing number. But we don't. So we have an issue somewhere. Yep, so the issue here is my length of the array. So range basically is not inclusive, let's say. So if we look at Python's range, it says produces a sequence, start is inclusive, but stop is exclusive, which means the last element is not generated. So we need +1 so that we can get to n. And so that normally should cover this case. So let's see. Yes, it does. Okay. One other edge case that we should account for, what if it's the one that is missing here? And we have 2, 3. So this solution should be 1, 2, 3, right? So the missing element is 1 and the duplicate is 2. Let's see if that works. So that works. So our solution should be good. Yeah, so the solution passed. Let's see. So we can solve this in a different with a different approach. So one hint here is the problem said that the array is not in any order. So that should get us thinking about sorting. So what if we sorted the array? So if we have a sorted array, that means that if an element is equal to the element before it, so if I minus 1 here equal to I, that means that we have identical numbers here. So this means that we have the duplicate found the duplicate. So we cover the duplicate case. What about the missing number? So if the element at I minus 1 is basically less than the element. So if the element here +1, let's call it, is less than names of I, that means that we jump it. So there is a missing number there. So that way we can find the missing number. So let's do that. So let's sort first the array. And then let's initialize a duplicate and missing variables. And let's initialize also just the length of the array. And so let's just put 0 here. We can put 0 here for the element, so put 1. For the missing, it would be replaced anyway. And let's put 0 just for. And let's put length here for n. And if we go through the range, same way we did before, we can check if the previous value. So we are going from 1 for the index, so that means we can do I minus 1. So if that is equal to I, that means we have a duplicate. And so our duplicate is going to be this value. Now, if the element at I is bigger, so this condition here is bigger than the element at I minus 1 plus 1, that means we have the missing number, and the missing number is this value here, since it didn't appear there. And that's basically it. We return duplicate and missing. There's just some edge cases that we need to handle. So if the array length is less than 2, then we might not have missing here. So we are going to say 0. So we are going, but it's initialized to 0. So that covers it. There is just the case of the last element, right? So we need to handle that. So if basically the last element is different than the length, then we need to return that last element. So let's run this. So we have one problem for the missing value here, should be 1. So we are not handling correctly the case where it's the first element. So this thing here, the problem is it compares only with the previous value. So what we can do here is Let's see. Let's think of how can we solve this. We can solve it by just assigning 1 here to account for the case where the array has, it's the first element. This is 1 itself that is missing. And for cases where, let's test this, it works for this case first. Okay, it works for that case. What about the case where we have an empty? Does this work? No, so we have a problem here because we are checking against an empty array. So we need to check that. So we need to say 0 if n is less than 1. Else, so we handle that case. What about the case where we have only 1 element? So we have an issue here because missing is initialized to 1. And since if it's only 1 element, we have an issue here. So we need to do also, so actually we need to do less than 2 here for this case. Okay, so always check your boundary cases. Empty list, 1 element, the value you are looking for is at the far left or is at the far right. Those are good things to always check. Okay, I'll submit this. Okay, so now this solution passes, good. Another clever solution that we can do is the following. So let's say we had, so what if we had, let's say, let's initialize names here, so it's our array. Now the set of names gives us the unique elements that are occurring, right? And so if we take the sum of all the elements and subtract the sum of this set, this basically will say 1, 2, 3, 4, the sum of that. So it would say the sum of this minus the sum of this, which will basically give us which give us the duplicate value. So this here will give us the duplicate value. If we do also sum of the range that we are expecting, which is 1, 2, 3, 4, which is length of names plus 1. If we subtract this from this here, we will get the missing value, which is 3. Because here it contains all the elements, here it contains all of them without the duplicates, and it doesn't contain the missing number. So if we subtract it, we will get the missing number. The wrong parentheses thing. Here. So that gives us 3, the missing number. So we can just use this solution here. So since we can just do here return basically the sum of what we did here minus the set. So that would be this. And for the other, it would be this. And that solves. Let's check with this example first. Okay, one small optimization is not to recompute this sum twice. So let's just say that sum here is equal to this, and reuse it. Submit this. Yeah, so that passes. So this is a very clever solution. Another additional way is a little bit complicated, but it's a nice constant space solution, and it uses, well, not constant, it's open, but it uses a map trick. So let's see that one. So we can build from the following. So we know that, so if we take x as the duplicate and say that y is the missing value, so that means that if we take the sum of all the numbers that we have minus the duplicate, adding the missing, we will get the sum from 1 to n, right? the sum from 1 to n. And that sum basically is just 1 plus 2 plus n, which, if we consider n is basically just the length of the array, right? And in mathematics, we remember that this thing has a formula. So if we look up something called Faulhaber's formula, we can see that the sum here of 1 plus 2 until n is n multiplied by n plus 1 divided by 2. So we can use that. So this is would be, this here is n plus 1 divided by 2, right? And the sum of, if we take like the square, like multiply each number by itself. So if we take num, or let's call it, num, for all the numbers in our array, and we subtract also x multiplied by x, and subtract and add y multiplied by y, this also would be the same thing as 1 multiplied by 1 plus 2 multiplied by 2 plus n multiplied by n. And this also has a formula. This is this formula here. So this is n multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. So this is n multiplied by n plus 1 multiplied by 2n plus 1, and the entire thing divided by 6. Okay? So we have this formula here. And so that means that x minus y is equal to sum of nums. So if we just take this value here and put it here, and take this value and put it on the other side. So that would mean minus this value here. And the same thing for this x here. If we put this on the other side and this value here on the other side, that means that this is equal to this sum here minus this value here, right? So to simplify for ourselves, let's call this one and then, so yeah, let me just first say, so if we take this and this, we know that this is equal to x minus y multiplied by x plus y, right? And from this solution, we know that x plus y is equal to this here, divided by this, right? So let's call alpha here, let's call alpha x plus y, and let's call beta x minus y, right? So that means we can find alpha is this, and we can find beta, which would be just this entire thing here, divided by alpha, because it's equal to beta, basically is x minus y, which is equal to this here divided by alpha, right? Which is equal to this. This value here is this x multiplied by x minus y multiplied by x by y is this value, and then we divide it by alpha. And from this formula, we can just find x and y. So if we do x and x plus y and just do the normal equation solution using plus, for example, right? So this would give us, so this is equal to alpha, and this is equal to beta, right? So if we add these up, we will get 2x equal to beta plus alpha, right? And this means that we get x is equal to beta plus alpha divided by 2. We can do the same thing for finding y, right? So except this time we'll do minus, and that means that we'll get minus 2y is equal to alpha minus beta, right? Which means that y is equal to beta minus alpha divided by 2. And so now we know how to calculate alpha, we know how to calculate beta, and we know how to find x and y. So let's just compute this solution here. So first we just put the length of the array in n. And from there, we are going to say, just hold this down. We are going to say, we are going to calculate alpha, which was just this. So we just calculate this. And beta, which was pretty much this value. And our result is going to be this and this. We just need to, since this will give us a float value in Python, we need to convert it to int and do the same thing here. And this should give us a good result. So let's see here with console. Okay, we have a slight problem. Yeah, we didn't add multiply here. There is a small issue. Yeah, maybe something weird happened here. Let's see. Yeah, so it was just the parentheses that were missing. Okay, cool. So let's test with, as always, with some edge cases. So let's say with just one value. So we have a division by 0, so we need to safeguard against when alpha is equal to 0. So if alpha is different than 0, if it's not different than 0, then we can just say else 0. Okay, so that works. Let's see what it is. Good. And the benefit of this using math solution here is that like these boundaries are taken care of. So if the last element is the missing one, we'll get the result correctly. So let's submit this, and that solution passes. Okay, see you next time. Bye.